On this today is an exercise 14F question 3H. So this question is about solving these equations, these exponential equations, and essentially the whole point of this exercise is about using a change of variable as well as potential use of logs to solve these equations. So in part H, we have this equation, and a very common technique is change of variables, and normally that happens when we have exponential equations in the form, let's say a to the power of 2x plus b x, b to the power of x, and actually, yeah, here must be a. So yeah, we have something in this form, as you can see. So the base numbers are essentially the same, and then the first power is of the order of 2. So sometimes you can have additional constants, and then the second power is just of order of 1. Now, which is obviously a form of quadratic equation. So in this case, before we start changing the variable, we can actually simplify this term first, because as I mentioned, we want to have this in the form a to the power of 2x. So we want to get rid of this plus 1 from the power. And a very simple way is just realizing that 3 to the power of 2x plus 1 is the same as 3 to the power of 2x times 3 to the power of 1. And then we can basically rewrite this in this form. So that means the equation becomes, so 4 times 3 times 3 to the power of 2x, just 2x, like this. And obviously 4 times 3 is 12. So because of that, we'll just have 12 times 3 to the power of 2x plus 17 times 3 to the power of x minus 7 is equal to 0. So it's a less obvious part of this question. Now we can use the new variable. So we can introduce the new variable t, which is equal to 3 to the power of x. That means the first term becomes t squared, because 3 to the power of 2x is just like squaring both sides of this equation, which means we'll get t squared. And then the second term is just exactly t. 3 to the power of x is t. Minus 7 is equal to 0. So we can now factorize, and it becomes 3t minus 1 times 4t plus 7 is equal to 0. So we just set each bracket equal to 0. The first bracket gives us 1 over 3. Second bracket gives us minus 7 over 4. Now remember that we need to go back and find the solutions in terms of, basically, because we want to find the value of x, right? We now have t, but we want to know what's the value of x. So we set each of these equal to 3 to the power of x. We have here 3 to the power of x is equal to the first solution, which is 1 over 3. And now we can take logs. So we have x log 3 on one side, because when you take log of a number that has a power using the power law, the power comes outside of the log and becomes the coefficient of the log. So with that said, the equation becomes this, and then to find x, we just divide both sides by log 3. So the answer is log 1 over 3 over log 3, but we need to give this to 3 significant figures. So, well, actually, before even using calculator, we didn't really need to use logs for this one, to be honest with you, because the exercise is about logs, so I automatically use logs. But when you think about this, you have 3 to the power of x is equal to 1 over 3, so it's very obvious that x is just simply equal to minus 1, right? So we didn't even need logs for this specific case. But for the second solution, so this is the first solution. Now for the second solution is when, so first case, the second case is when 3 to the power of x is equal to minus 7 over 4, because that's the value of t. But there's a problem, because this one has no solution, because there is no value of x such that when you have 3 to the power of x, then the answer is negative. So it's never going to be negative. So therefore, we don't find any solutions if t is equal to minus 7 over 4. The only solution is minus 1.